Welcome back to All This Math. This is Professor Parker. Now, you know the routine if you've seen these videos before. You know what I'm going to say. Make sure you are subscribed to the All This Math YouTube channel. Make sure you like this video, right? If you like the video, make sure you drop a comment down below, right? If you're so inclined. And also, don't be selfish. Make sure you share this video with at least one person, at least a few people. Put it in the group chat or whatever. Somebody definitely, inevitably, I promise you, you know somebody that needs help with this type of problem that we're about to get into. This is an addition problem, right? And I want us to be able to do problems like this in our heads, right? Our first calculator. Our brain is our first calculator. We don't necessarily need to go grab the calculator, go grab the iPhone, go to the calculator app. We don't necessarily need to do all that. We should be able to do the mental math in our heads. And there's a few ways to do a problem like this. But first, let's read what it says, right? These are our add-ins. This is an add-in. In an addition problem, you have terms that are called add-ins. Some textbooks call them sum-ins, right? That's just what they call. It might be called some other things that I'm not aware of, right? But negative 13 is an add-in, 28 is an add-in. When we add numbers together, our result is called a sum. A sum. When we multiply terms, our result is called a product. When we divide terms, our result is called a quotient. When we subtract terms, our result is called a difference, right? So we're looking for the sum, right? Right? This is basically an algebraic equation because if I put a variable right here, then we'd be solving for the variable, whether it be x or y or z or a or b or c or whatever, right? Keep that in mind too. All right, so negative 13 plus 28. Let's think about that conceptually, right? This is kind of abstract, right? But what if it was a real life situation? Let's say you're an adult or a teenager. You have a bank account, checking account, right? You make a mistake. You overdraw your account. You didn't balance your checking account, right? You withdraw your account, you spend too much money. Now you're in a hole. The checking account has a negative balance. Negative $13. Negative $13. Now, let's say you bought something from a store, didn't work, you didn't like it, you returned it, and it was worth $28. They give you a refund. That merchant gives you a refund. So that merchant adds $28 to your checking account that is overdrawn. A lot of people make the mistake. They don't know how to balance their checking account. They think they have a $28 balance because somebody deposited $28. No, you would only have a $28 balance if you start from zero, but you're not starting from zero. You're starting from negative 13, right? Similar to how racism works in America. Black people are not starting from zero. We're often starting from the negative, below zero, less than zero, right? So when people say things like racism doesn't exist, or we're all in this together, we all had just as much opportunity. No, this is untrue. This is disingenuous. This is a falsehood. We're not all starting from the same point. Everybody's not starting from zero, right? Like this situation. Your checking account is starting from negative 13, right? The people that are starting from zero, they have what's called a head start, right? Whether they want to believe this or not. But this is a deeper conversation for another time. But anyway, just back to our point. We start from negative 13 and you add 28, right? Imagine a number line. If I had a number line drawn right here, negative 13 will be over here on the negative side. Whenever you're adding, you're moving across the number line to the right. Whenever you add, you're moving to the right. Now, this number, the second add-in, tells you how far you're moving, how many steps you're taking. You start at negative 13, you're going 28 steps to the right. You're going to cross zero. You're going to end up at positive 15. Positive 15, right? If you would have counted out, right? Now, this would be much nicer if I actually had a number line, taped to the wall like a lot of math classrooms do, or if I had drawn a number line, on the board. But I decided not to do that. But another way to think about this problem is you can also use the commutative property because we're doing addition. Now, what is the commutative property? You might have never heard of the commutative property before. So I'm not going to be one of the math teachers that's just going to throw a term at you and just expect that you know what it is. The commutative property is a property that says this. It says that when you're doing addition or multiplication, you can change the order of the terms. In an addition problem, you can change the order of the add-ins, and your result or your sum will still be the same number. Your sum will still be the same number. In a multiplication problem, you can change the order of the factors, and your product will still be the same number, right? In a multiplication problem, 3 times 2 equals 6. I switch the 3 and the 2, and I do 2 times 3, that also equals 6. In an addition problem, 2 plus 3 equals the sum of 5. If I switch them around in order, 3 plus 2 also equals 5. You see what I'm saying? That's the commutative property. So run that back and then hit play, write that down. You need to know what the commutative property is. Make sure you know what the commutative, it's called commutative. Commutative property. It's, you know, you're probably learning alongside the associative property, the distributive property. You know, it's a lot of properties in math that just enable us to do certain things where we manipulate numbers, move numbers around, you know, do all types of things to make the math easier and to enable us to do mental math and to solve problems. That's what math is all about. It teaches us how to solve problems. That's what this is all about. All right. So now, if I use the commutative property and I switch the order of the two numbers, now I got 28 plus. Now, what am I doing? Where these parentheses come from? Why am I doing that? Only reason I'm doing that is because I might not want to have a plus sign right next to a negative sign. All right. Now, some people get confused when they say, well, I thought that was a negative sign, but it looks like a minus sign. Minus signs and negative signs are basically the same thing. Maybe not exactly, but they basically mean the same thing. This will be referred to as a negative sign. It's almost like an adjective in, you know, ELA, or English language arts, right? You have an adjective. An adjective is a word that describes a noun. In this case, the 13 is like a noun. The negative sign tells you that, oh, this is a negative 13, right? So negative is an adjective. So this negative sign describes this 13. So it's a negative 13. The plus sign is a verb because we're actually adding. It's an action. To add this to this is an action. So the plus sign is a verb. 13 is a noun. 28 is a noun. The negative sign is an adjective. So you say, okay, 28 plus negative 13. Now keep this in mind. Put this in your notes, right? So I'm about to give you a jewel. Adding a negative is the same thing as regular, what I say to my students all the time, regular subtraction. That's regular subtraction, straight subtraction. 28 minus 13. Whenever you see a problem written like this, you see an addition sign and then a minus sign right after it. The parentheses are really immaterial here. But a plus sign, then a minus sign, that's the same thing as regular subtraction. That's what it is. It's the same thing as regular subtraction. All right, so if it's regular subtraction, you treat it like it's regular subtraction. That's how I got the answer 15. What's 28 take away 13, right? There's a few ways to do that, right? Without a calculator. If I'm trying to take away 13, it might be easier for me to say, you know what? Let's decompose. Textbooks say decompose. I really don't generally use that type of language in everyday life, unless I'm talking about something scientific, something more scientific, you know, like a decomposing organism or whatever. I might say break down. So I'm going to break the 13 down into 10 and 3, right? And then I can, instead of having one subtraction problem that might be a little more complicated, don't be embarrassed if it is, right? I break it down into 2 separate subtraction problems. I might do 28 take away 10 first. Imagine you had $28 and then you spent $10. How much money should you have left? You should have $18 left because 28 minus 10 is 18, right? So 28 take away 10 is going to be 18. Now you got 18, but you still got to take this 3 away. So once we take the 10 away, now we got 18. And we take the 3 away, now we got 15. So it's a lot of ways we could do this. It's a lot of ways we could do this, right? We can do these problems in different ways, right? Or you might just know, or you might have wanted to do this. You might have said, well, what if I did 28 take away 3? And that gave me 25. And then you do the 25 take away 10. Which gives you 15. There's so many different ways to get 15. So many different ways. There's so many ways to get answers in math, right? You should familiarize yourself with all of them. You should experiment. Play around with the problem sometimes. You know what I mean? Like, just, you know, just see for yourself. See for yourself there are different ways to do algebra. This is essentially, well, this is like what we would consider pre-algebra, right? But it really is algebra, though, really. It just depends on who you ask. So anyway, like I said, you can do this problem with a number line. Familiarize yourself with the number line. I learned how to do these types of math problems when I was in 6th grade using a number. My teacher taught me using a number line. I never forget it. I always think about the number line whenever I'm dealing with positives and negative numbers, right? You could also decompose is one of the numbers, or what's called the, oh, I ain't even tell you. Keep this, right? Since we converted this addition problem into a subtraction problem, these terms have names. The first term in a subtraction problem, right, in case you're up on Jeopardy or whatever, and it's one of the answers, right, is called a menu end. Min-u end. E-N-D, like the end of a movie, right? Min, like minimum, then the letter U, and then end. Min-u end. No, I don't feel like writing it on the board. Min-u end, right? The second number, the number that's being subtracted, is called a sub like subtract, subtra, T-R-A, right? Tra, hend. Subtra, T-R-A-H, end. Like the end of a movie again. Menu end and subtra, hend. Menu end and subtra, hend. All right? First number is the menu end, second number is the subtra hend. So it's different things we could do. You know what I mean? So you could break down the subtra hend into smaller numbers. You know, this is how it's taught, like, you know, in elementary school, like first and second grade, when your children are subtracting numbers like this, right? They're taught to decompose the second number, right? So that it makes the subtraction easier, right? Because it's typically easier to subtract 10 from any number. You know why? Because if you subtract 10 from a number, only the digit in the tens place changes. Notice how if I take away 10, I'm going from 28 to 18. And if I take another 10 away, I go from 18 to 8. Notice that the number in the ones place does not change when you subtract by 10. When you subtract by 10, the number in the ones place does not change. Right? Some people believe that makes the problem easier. So whatever works. But again, I think I said this earlier in the video, it's important to be flexible. You should learn as many different methods as possible. So parents, when your children come home with homework, and the teacher says, I want it done like this, or you try to help your child and use the method that you learned 35 years ago, and your child looks at you and says, no, my teacher doesn't want us to do it like that. Don't get frustrated. Relax, take a deep breath, calm down, lock in, and make a decision to learn the method that the teacher wants your child to do. It's going to help them, right? Don't rob your child of the opportunity of learning a new method. Your method might be fine. You should teach your child the method you learned 35 years ago too. Just because you learned it 35 years ago doesn't mean that it still doesn't work. I'm sure you understand that. It still works. But you don't want your child to be limited to what you know. And what's the worst that could happen? You learn something new yourself. So now you got two ways to do the problems. Maybe something you never learned 35 years ago. See what I'm saying? Look at the bright side. All right? So again, make sure you subscribe to the All This Math YouTube channel. Make sure you drop a comment down below. Make sure you like the video. Make sure you send it to a bunch of people. All right? I'll see you all on the next video.